Cryptography. Cryptography is a method of securing information, whether it is at rest or in transit. Without cryptography, hackers would be able to see all of your information in what is called plain text. This means that your usernames, passwords, and other important information would be clearly visible if someone could access your network or device. You will learn how to view these plain text messages in the tutorials on network forensics. These days, cryptography is based on mathematical algorithms and other automated processes that encrypt your information. This takes regular messages that are in plain text and converts them into complex variations that are hard to decipher. Everything needs to be encrypted, whether it is data in a memory file or data being transmitted over a network. This makes communication between computers and devices more complicated and sometimes less efficient. However, without this, all of our information would be visible and accessible to adversaries. This section will explain some of the key concepts and terms relating to the topic of cryptography. Cryptography terms. Plain text. Plain text, as described above, is text-based information that has not been encrypted in any way. For example, the words, "Hello, how are you?" is an example of plain text. If this message was sent over a computer network without encryption, then someone using a protocol analyzer would be able to see it as written above. This may be fine if you are communicating just for fun on an internal network not connected to the internet. However, when communicating sensitive information such as when logging into your bank account, you always want to have multiple encryption protocols operating at various layers. Initialization vector. This is a random number that is used in combination with a secret key, which helps to encrypt the original message. This adds a level of randomness to the ciphertext, so it is harder to decipher. Hash functions. A hash function is a process by which a section of text is converted into a specific value, which creates pairs of keys and values which correspond with one another in a table. This allows an integer to be used as an index in the hash table instead of plain text, which must remain secured. There are several types of hash functions that use numeric or alphanumeric keys. Examples include division method, mid-square method, folding method, and the multiplication method. Learning about hash functions in detail is an advanced concept that is not needed for this training. However, resources have been provided if you wish to continue your studies on this topic. Ciphertext. Ciphertext is the encrypted message after it has been converted from plain text. Ciphertext will take on many forms based on what cryptographic techniques are being applied to the information. A simple formula to understand ciphertext is listed below. Plain text plus initialization vector plus encryption algorithm plus key equals the ciphertext. Symmetric encryption. Symmetric encryption uses one key that is shared between all parties in order to access the encrypted data. Symmetric encryption is faster but less secure and is considered an older method of encryption. It is less secure because you are trusting all parties to use one key in order to decrypt the secured data. This means that you must trust everyone in your organization, to include those who no longer work for that organization. If you think that a certain party can no longer be trusted, then you have to change the secret key for everyone in the organization. This quickly becomes very inefficient or insecure, depending on your course of action. Common symmetric encryption standards include the Advanced Encryption Standard, AES, which replaced the older Data Encryption Standard, DES, Blowfish, Twofish, and 3DES or Triple DES. Asymmetric encryption. This type of encryption uses a public key for encryption and a private key for decryption, which is held by each individual. This two-key system allows for better security, but comes at a cost with higher resource consumption and subsequent slower speeds. Common asymmetric encryption standards include RSA and elliptic curve cryptography, ECC. RSA 2048-bit keys are the current banking standard. However, elliptic curve cryptography is quickly overtaking it, as it is much more complex and secure. Elliptic curve cryptography will likely become the future standard for encryption, as it is exponentially more powerful than RSA. Stream cipher. A stream cipher is a type of symmetric key encryption that converts each plain text symbol into a ciphertext. Each team's cipher functions by creating a corresponding random bytes that depend on a key for encryption and decryption. Stream ciphers are more susceptible to insertions and modifications, but is less susceptible to diffusion, because as translation is byte to byte. Block ciphers. Block ciphers are used when entire blocks of data are encrypted versus single bytes at a time. This creates high diffusion, which spreads the data into several ciphertext symbols. This makes the process slower, but more difficult for an attacker to make insertions or modifications without detection.